Hi, I'm Onvi, and today I will be walking you through Module 3, Activity 2, the shade test. The summary. Teams will hold the Lunasat at different angles relative to a strong light source and measure the voltage outputs. Teams will find materials with different opacities and cover the solar panels on the Lunasat to see a difference in voltage outputs. Then teams will figure out at what angle and amount of direct light the Lunasat works best. The goal for today is for teams to observe the variation in power due to varying light input. The materials and code needed. The materials needed is your Lunasat, a computer with Arduino, connection cords and jumpers, FTDI and USB cable, a strong light source, the sun is best but another light source works, a protractor, which is optional but suggested, and 3 materials of varying opacity: saran wrap, ESD tape, wax paper, printer paper, etc. And the Activity 3.2 worksheet shade test. Please follow along. The code we will be using is the Lunar Solar Panel Voltage Code, and to find that, we are going to go to Files, and then Examples, and then GLE 2023, Module Sketches, Module 3 Solar Panel, and Lunasat Solar Panel Voltage. We're just going to open that right up. The step 1 is our setup. Uninstall P1 and P3 jumpers from the previous activity, install P8 and P6 jumpers, and connect the Lunasat to the FTDI. For this activity, keep the Lunasat plugged into the FTDI and the computer. Step 1 is to upload the code. Select the correct board, processor, and port. So we are going to go to Tools and then select the board we are using. Select our preferred processor and our port as well. Just double checking all of those. And then we are going to load the file onto our Lunasat and then verify it and upload it. Perfect. Then we are going to open the serial plotter. So Tools, Serial Plotter. Okay, there we go. We're going to open our serial plotter, and then our next step is going to turn off any ambient lights in the room, put the Lunasat under a strong source of direct light, and your phone flashlight should work, and then manipulate the Lunasat and the light source to observe different relative angles. Your boxes can be useful to prop up your flashlight if needed. Take a note of the angle using a protractor and the voltage outputs for each position. As you can see, the voltage outputs are presented on my serial plotter. Our next step is going to choose an orientation. Keep the Lunasat under the strong source of direct light. Pick a control orientation, choose an angle, and keep it there for the remainder of the activity. We suggest 90 degrees. Use 3 materials, items with different opacity, and the expected voltages, if you use plastic wrap, would be 1.5 volts, a wax paper, 1.3 volts, and printer paper, 0.9 volts. Step 5 is to change the amount of light. Hold each material over the Lunasat to shade the solar panels. Measure the voltage outputs for the different materials. And then, to avoid confusion in the next module, we are going to return both Lunasats to the original bridge connector configuration by leaving only the P6 jumper installed. Thank you for going through this activity with me.